So in this part, we're going to talk about parallel and perpendicular linear equations. So to sum up, parallel equations or parallel slopes is mean that when you have two slopes that are exactly the same. So here, slope 1 and slope 2, m sub 1 and m sub 2, are equal to each other. So an example is that if your first slope, say m sub 1 is equal to 2 over 7, then if m sub 2 is to be parallel, that means that they have to have the same slope, which is 2 over 7. Now, if you were to talk about like the graphs, so for example, here's two lines. So this one is f of 1 of x, and then f of 2 of x. So if you closely look at these two graph lines, they are parallel to each other. If they're parallel, that they're never going to intersect to each other. So in order to be parallel and never touch each other, never intersect each other, they must have the exact same slope. Doesn't matter what y-intercept they have, it's just that the slope has to be exactly the same. If the first slope is positive, then the second one has to be positive. If the first one is negative, then the second one has to be negative. In order for two slopes to be parallel, they must be exactly the same. Now let's talk about perpendicular. Perpendicular is when they are opposite reciprocal, meaning that if you have a slope, the first slope, m sub 1, then the reciprocal is negative 1 over m sub 1. So that would be the general rule. So if, say, your first slope is m1 is positive 3 over 5, then you must follow the rule, opposite reciprocal. So my second slope, m sub 2, first it has to be opposite. So since f sub 1 is positive, then f sub 2 is negative. Reciprocal means to flip. So that's what happens when you put 1 over the slope or 1 over a fraction. You're just doing the reciprocal. So the reciprocal of 3 over 5 is simply 5 over 3. So these two slopes are opposite to each other and reciprocal, so these two slopes will be perpendicular. Now, say you have a whole number, m equals to, say, 2. And you're looking for a perpendicular slope, so m sub 2. Basically, if m sub 1 is a whole number, you just follow this rule. So you want to make it negative, and then just put 1 over 2. Now, how you know that they are reciprocal? Remember, to convert a whole number into a fraction, you're just going to put the whole number over 1. So 2 over 1. So that's how you would convert a whole number into a fraction, and then you just do reciprocal. You're going to flip it, which is 1 over 2. So again, if m sub 1 is 2, then m sub 2 is negative 1 over 2 in order for these two slopes to be perpendicular. So again, in order to find perpendicular slope or determine if they are perpendicular is if you see that they are opposite to each other, one is positive, one is negative, and they are reciprocal to each other. So here 3 over 5, reciprocal 5 over 3. Over here 2, 1 over 2. Now in order to determine that they are actual reciprocal, you just multiply the two slopes together. So for example, 3 over 5 times 5 over 3, it's negative. So you're going to get negative 15 over 15 because again, numerator times numerator, denominator times denominator, that will be equal to negative 1. So if m sub 1 times m sub 2, when you multiply and it equals negative 1, then they are perpendicular. So let's do the other one. 2, and then converting 2 into a fraction, just put 2 over 1 times negative 1 over 2. So when you get that, it's going to be negative 2 over 2, which is negative 1. So again, they both equal to -1, therefore they are perpendicular to each other, as long as they follow opposite reciprocal. So in our first example, we have 5x minus 2y equals to 12, and then the second equation is -20x plus 8y equals 16. So here we're going to determine if these two equations are parallel to each other, perpendicular to each other, or neither. So in the event where the slope are not exactly the same, or the slope are not opposite reciprocal to each other, then they are neither parallel nor perpendicular. Alright, so let's convert the first equation into slope-intercept form. So what I'm going to do is subtract 5x, because again, to get slope-intercept form, you just need to get a y by itself. So I'm going to get -2y equals -5x plus 12, because it's positive. Divide both sides by -2. So here I'm going to get y equal to -5x divided by -2 will be positive 5/2 x. So positive 12 divided by -2, which will be -6. Now here, my slope is the number in front of x, so m1 is equal to 5/2. And then the second one, so -20x plus 8y equal to 16. So to get y by itself, I'm going to add 20x to both sides. I'm going to get 8y is equal to 20x plus 16. Then I'm going to divide both sides by 8. Y equals to 20 over 8x plus 16 divided by 8 is 2. Now, I can simplify 20 over 8. Top and bottom, numerator and denominator can be both be divided by 4. That's our common factor. So I'm going to have y equal 5 over 2x plus 2. Here, m sub 2, the slope is 5 over 2. So all you have to do is first convert both equations into slope-intercept form, getting the y by itself, and then check with the slope. So these two slopes are exactly the same, so therefore they are parallel to each other. And then that's all you have to do, and then I'm just going to box that up. Parallel to each other. In this next example, we have two equations. The first one, 4x plus 3y equals 15. The second one, -12x plus 16y equals 3. So again, determine if they're parallel, perpendicular, or neither. So I'm going to convert the first equation into slope-intercept form. So again, I'm going to cancel out my x. So here I'm going to subtract 4x to both sides. So I'm going to get 3y equal -4x plus 15. Divide both sides by 3. So here I'm going to get y equal -4/3 x plus 5. M sub 1 will be -4/3. Alright, so let's take a look at the second equation. So -12x plus 16y equals to 3. So I'm going to cancel out the x. So I'm going to add 12x to both sides. So I'm going to get 16y equal to 12x plus 3. Then I'm going to divide both sides by 16. So I'm going to get y equal 12 over 16 x plus 3 over 16. And then I notice that I can simplify 12 over 16 by a factor of 4. So I'm going to divide top and bottom by 4. When I do that, I'm going to get y equal 3 over 4x plus 3 over 16. Don't mind the y-intercept. The main focus is the slope. So m sub 2, the slope for this equation is positive 3 over 4. So looking at slope 1 and slope 2, they're opposite to each other because one is negative, one is positive, and they are reciprocal to each other because 4/3, when you flip it, is 3/4. And if you were to start with 3/4, when you flip it, it's 4/3. So therefore, these two slopes, these two linear equations, are perpendicular to each other. And let me box that up. So again, they're opposite to each other, and the slopes are reciprocal to each other. And it's going to be the same process when you determine if they're parallel, perpendicular, or neither. Convert into slope-intercept form. In this third example, we have our first equation, 2x plus 3y equals 4. The second equation, negative 5x plus 6y equals to 12. Alright, so let me convert the first equation into slope-intercept form. So I'm going to subtract 2x on both sides. So I'm going to get 3y equal negative 2x plus 4 since it's positive. Then I'm going to divide both sides by 3. So I'm going to have y equal negative 2/3 x plus 4/3. So my first slope, m sub 1, is equal to negative 2/3. So that's my slope. Alright, now let's take a look at the second equation. So negative 5x plus 6y equal to 12. So I'm going to add 5x to both sides. So it's 6y equal to 5x plus 12. Then I'm going to divide both sides by 6. So I'm going to have y equal 5/6x plus 2. Nothing else to simplify, so my second slope is 5/6. Now let's take a look. When we're comparing between slope 1, slope 2, they're opposite to each other because one is negative, one is positive. But if you look closely, they are not reciprocal to each other because if you were to flip 2/3, this should have been 3/2. And if you do the reciprocal, meaning flip 5/6, then this should have been 6/5. So they're not reciprocal to each other, even though they're opposite. Since they're not reciprocal, then they are not perpendicular. Since these two slopes are not exactly the same, then they are not parallel. So following those conditions that I stated, not reciprocal to each other, even though it's opposite sign, still not perpendicular, not exactly the same, therefore not parallel. Therefore, these two slopes are neither parallel nor perpendicular to each other. So I'm just going to write neither. And that will be my final answer. Neither. For these two equations, they're neither parallel nor perpendicular.